The next pattern of inheritance, which we'll be looking at, is the sex-linked pattern of inheritance, in which the alleles are only affiliated with the X chromosome. This is because the Y chromosome is much smaller than the X chromosome, making the X chromosome the only holder for alleles. Now, sex-linked diseases and disorders are most common in men because they only have a single X chromosome. They do not have a backup like females, and it's important to note that sex-linked patterns of inheritance follow the rules of complete dominance. So if you were to categorize a disease with the allele lowercase h and a healthy person with the allele uppercase H, we see that females, if they have both uppercase H's on their X chromosome, that they're perfectly healthy. If they're heterozygous, they're still perfectly healthy, but they're carrying the disease. And if they have both recessive, then that means that they are affected by the disease and they are physically affected. With males, you cannot be a carrier. You either have the disease or do not have the disease. If you have one uppercase H, then you are healthy. And if you have one lowercase h, then you are having the disease. Now, if we look at the images to the right, you find that there is in the top image, there's a healthy male who's having offspring with a heterozygous carrier. And we see that there's only 25% chance of their child having the disease, and that child must be a boy in order to have that disease. And they have a 25% chance of having a carrier child, and the child must be a female to be a carrier. Now, if we look at the one on the bottom, we see that there is a healthy male who's having offspring with an affected female. And we see that 50% of the offspring will be affected by the disease, and if the child is a boy, then they will definitely have the disease, and if the child is a female, then they will have to be a carrier of the disease. This is a practice problem on sex-linked inheritance, and it goes like this. In humans, the gene for normal blood clotting, which is X uppercase H, and is dominant to the gene for hemophilia, X lowercase h. This is a sex-linked trait found on the X chromosome. A woman with normal blood clotting has 4 children. They are a normal son, a hemophiliac son, 2 normal daughters, and the father is normal for blood clotting. Draw a pedigree that includes everyone mentioned in the story. Okay, so I'm going to begin by drawing my Punnett square of the father and the mother. I know that both the father and the mother are normal for blood clotting, so the father has to be X uppercase H, Y, and they have a hemophiliac son, so that means that the mother has to be a carrier. So as I fill in the Punnett square, I find that there is only a 25% chance of having a child who has hemophilia. And I'm going to draw the pedigree of the 6 people. So I'm going to start with the mother. And I'm going to fill in half because this symbolizes that the person is a carrier. And I'm going to draw the father, who is perfectly healthy, so the box is clear. And I'm going to draw the genotypes above the individuals and the line that marks the children. And then I'm going to draw the normal son, who has X uppercase H, Y, and then the hemophiliac son, who has to be X lowercase y, X lowercase h, y, and the 2 daughters. The 2 daughters can either be carriers or homozygous dominant. It's unknown, and the genotypes are not disclosed in the description of the problem. It just says that they're healthy, so they can be heterozygous or homozygous dominant. Now, we completed writing the genotypes, and if they decide to have another child, what are the chances the child would be a girl who carried the disorder? Well, there's only 1 box out of the 4, so that's a 25% chance. And this was a practice problem, and I hope you enjoyed this video on patterns of genetic inheritance. Thank you.